streaming in from Russia. Bitfury, who you probably know, has been around the space for a long time, starting out predominantly as a Bitcoin mining company, but have expanded their verticals to kind of encompass various things to support very much the Bitcoin industry in general. So they've been working on a Lightning implementation from the very beginning, one of the teams doing so. So we're really pleased to welcome the head of that team, Lightning, which is known as Lightning Peach, Pavel Prikhodko. Hopefully I said that correctly. And I'm just about to hopefully plug over and introduce Pavel here, and he'll be joining us in the room now from Russia. Over to you, Pavel.
Okay. Hi, everyone. I hope you can hear me. I'll just switch to my slides. Just wanted to say hi, and we'll proceed with the presentation. So, hope you see my slides. So, yeah, I'm Pavel from Lightning Peach, and I'm gonna speak about what's gonna appear in the Lightning Network protocol soon, or maybe not so soon, but still important enough to appear. First of all, let's start with some network overview. If you look at the Lightning Network from somewhat bird view, you see quite a bright picture with most of the numbers, overall numbers on the network being quite good and promising, almost exponential growth lately, with most of the major metrics having 2 digits improve monthly, which is kind of great. However, these metrics are not direct indicators of actual network activity, actual network economics, because the Lightning Network itself is defined in such a way that it's really hard to track. I mean, unlike other on-chain Bitcoin transactions, in Lightning Network, it's almost impossible to track all the transactions, amounts, and destinations going over the network. So it's really hard to guess how much work this money and channels created the networks really do. The best instrument we have to actually look at that is to get the statistics from the big nodes or wallets in the network, like the numbers I think Igor presented in the previous talk. The other interesting object in the network to look at is LNB project. It's actually 20 nodes located in the network with a capacity of 32 Bitcoins put into each node. So total it's 440 Bitcoins, which in the current exchange rate, more than $3 million, which is quite big amount of money. These nodes are really well connected. I think they are connected to most of the big nodes in the network, and they allow you to do inbound channels to them, to get inbound capacity from them. So they're really well connected, and provided they don't take a large fee for processing transaction, they should have a great deal of, maybe even majority, I don't know, transactions on the network processed through them. So looking at them may be a good indicator to see how much money actually flows through the network. And the good thing is that they actually provide this data openly, and the numbers are shown on the screen. So the daily amount of transaction is just around 700 transactions, which finally reminiscent to the number of transactions they have in the Blue Wallet. So maybe all the activity in the network is generated by Blue Wallet, I don't know. And the total amount of money transferred daily is just $10,000, which is not a small amount of money, of course, but it's not that big, provided they have 3 million put into the channels. The question is why. Maybe one answer is that because there is not so much incentive in the network yet to spend all this money, and I really hope this will change soon, because there are so many different projects and teams working on lots of interesting stuff for the Lightning around the globe. So that may change. The interesting way to spend your money on may appear in 2019. But I think the other reason is that there is still lots of inefficiency in the network in a way how channels are handled, in a way on how this should be managed. So meaning that there is still there's still big room for improvement. So to summarize this, the network shows good dynamics, but as far as we've seen, it's still mostly enthusiasts running the nodes for fun. So with no goal to really spend the money. The protocol itself is usable already, which is great, and it can be used by pretty much everyone on mainnet already, but it's still in beta stage, and it still have a number of issues and security shortcomings. So it's still kind of reckless to use it every day. And that's changing gradually, and again, by the end of 2019, the picture may improve greatly, I hope. And there are actually many people working on improvement, joint collaboration of Lightning Core developers introduced a next specification, which is version 1.1, that would include around 29 additions to the protocol. A majority of them, of course, are technical, so I will not describe them here because it's quite a very high-level talk. But lots of things are going to happen in the protocol, and in each implementation, and in our implementation as well, people try to introduce certain experimental features to think how this would work with the nodes, with the clients. Unlikely, these features today are rarely introduced into protocols, so mostly they are incompatible with each other. I mean, they are incompatible between different implementations. So for this talk, I listed a number of for this talk. I listed a number of things I want to tell, nice features that I think are important to be added to the protocol, and let's just start going through them and describe what that's about. Just want to make sure do you hear what I say, because I see Paul being a bit anxious. It's fine. Yeah, okay. Is a proper introduction of backups to the network, because as many people still don't realize or don't know, especially the ones who are used to working with conventional Bitcoin wallets, in case with Lightning Network, it's not enough to know your passphrase to reclaim all your funds. So you still could reclaim all your on-chain funds, but the money locked in the channel, in case your wallet is corrupted or the hard drive is destroyed, may just be lost forever. And even in case you do some backups store in the channel history, you still need to have the latest channel state, which is not obvious task, as the state may be updated really quickly. Because if you it's not perfect, but at least it allows you to understand if you have an outdated state, so you may request updated state for the other party. And if he's friendly towards you, don't try to cheat you, you will get updated state and you're good. However, if, for instance, you lost all your channel information, then you're in a really bad situation, because you do need, for instance, some data to recreate the private key for each channel. And if you've lost them, even if the other party tries to send the money to you or closes the channel unilaterally, you still can't reclaim the money, which is really bad. Luckily, recently to LND master branch, the static channel backups mechanism were introduced to solve this. The approach is that they create a file storing some channel-related data, which is enough to restore all the settled funds from the channel, in addition to all the on-chain balance, which restored using the passphrase. So in case you lost all your channel's data, or you just have your phone with a node broken or computer destroyed, I don't know, you still have a certain procedure to initiate that would close all your channel. And for that, you need a cooperation from the other side. But the bright thing is that at least you will be able to reclaim your settled funds. By settled funds, I mean funds that are not inter NHTLC. Okay, yeah, so at least you have some option to reclaim your funds, even if you lost everything. And yes, it's not yet perfect, and there is no working solution to actually have an actual backups store your current channel history. But let's hope it helps one day. Current situation now, at least is much better than it used to be like half a year ago, where the wallet loss meant losing all your money, which made Lightning practically unusable for any real money storing. The other important thing I want to describe here is a Sphynx messaging technique, which is quite simple by itself, but introduces the ability to create other cool features on top of Lightning. The feature is about the following thing. In the payment route onion packets sent in Lightning, they always use a fixed packet length of 1,300 bytes. It's done intentionally to conceal from the intermediary nodes the actual hop count from sender to destination, though they don't able to guess where the route would end, who the sender is, who the receiver is. But the current specification allows the hop path for to be as long as 20 hops, which is much longer than typical road path you have in the Lightning network. And to store data for each hop, it takes around 65 bytes in the packet, encrypted so that only the node that this hop data is intended for could decrypt it. From this decrypted data, it could get the fee data, the data on the previous node and the destination, the data on the node, next node and the destination. But anyway, as the packet contains data for 20 hops and the actual road length is 5 hops most of the time, it gives around almost a kilobyte of storage space per transaction wasted. Good thing is that one could actually utilize the space. I mean, this otherwise wasted space could be encrypted with recipient key and contain some arbitrary information used for some, for different purposes. It could contain some, specific data like IP code data, account ID data, whatever. But the thing is that it could also be used to introduce additional utility to network, because with this mechanism, as I will show you later, you'll be able to introduce such anticipated features as atomic multipath payments, spontaneous payments, when you don't need to generate payment request before sending a payment, and some, specific but still funny features like secure chats, or like using, basically with this you can even use you could even use Lightning as a transfer media for, say, some text, video, image data, with the benefits that no one would be able to sniff who sends the data, where the data is sent, and what the data is. So there is really room. I mean, no one really explored it yet to its fullest, but there is really room for secure data sharing messenger placed inside the Lightning Network. It has potential for that. But coming to the mentioned features that I already planned, like atomic multipath payment, it's again one of the really important feature to appear in the network because of the following. Currently, when you want to increase the channel capacity, you typically open another channel to the node. For instance, I open a channel with my friend for like $2, but I think that it may be too small because I may want to send a larger sum. So I open another channel for another $2, and now I have two channels for $2 each, so $4 totally. But the thing with the current protocol is that I still wouldn't be able to send a transaction with more than $2 because I just need to use one channel at a time, which is not good. Of course, I could split it and, for instance, set if I want to send $3, I may send $2 in one transaction and $1 in another transaction. But in this case, I would lose atomicity. So I may be stuck in a case when like send $2 for a $3 coffee and want to send another box, but my phone battery is dead. So we are stuck somewhere in between, which is not good. If you want to buy some goods, for instance, in the store or something like that. Possible solution for that is exactly the atomic multipath payment. How the thing is that you split one large payment into several smaller ones, independently route them through the network, but the recipient could only settle them only if all the partial payments reached its destination. This feature is cool thing about this feature is it's really easy to introduce. It uses the Sphynx messaging technique I mentioned on the previous slide, because you could just do as simple as that. You could just create a certain secret from which every pre-image for partial payments could be generated. You could split the secret into as many parts as many partial payments you have, and send each part of the secret with each partial payments. In this case, recipient would be able to generate pre-images for each partial payments and start actually settling them only in case he collected all the parts of the secret, so he recreated the full secret. So it's relatively simple to introduce, and I hope this feature will appear soon, because if we have it working on mainnet and compatible across different implementation, it would really boost the liquidity of the network, because in the current situation, when you plan to send a certain amount of money, you could send only as much as the smallest channel on your route allows you to send. And with atomic multipath payment, you would just bypass this limitation, which is kind of cool. And another, I think, one of my favorite features that I would really want to see implemented soon is the splicing. It's kind of resembles atomic multipath in what it's do for the user, but it works differently. The thing is that now if you want to change the channel capacity, you don't have much options. For instance, if you want to increase the capacity of the channel between you and the other party, the only solution you have is to actually open another channel, and then another channel and another one, which introduces all the complexity mentioned above in handling big amounts of money and understanding how much money you could send now. For instance, we are running a node now, and we have a connection with a Blue Wallet node. And I think we already opened like 5 or 6, or maybe even more channels between us, which introduces lots of the micromanagement you just want to avoid typically. If you want to, on the other side, if you want to claim some funds from the channel to decrease its capacity, for instance, if you want to pick the fees you earned for your routing or something like that, the only option you have now is to actually close the channel completely, then reopen it. And to reopen it, you need to again negotiate with the other party. And in case you are not satisfied with channel funded from one side, you need to introduce some way to create inbound capacity, which again is just activity you typically want to avoid. And last but not the least, when you close and reopen the channel, you just have wait for 2 transactions, so longer confirmation time, and pay 2x on-chain fee, which also not pleasant. But there is a good solution to that. That would kind of blend the border between on-chain and off-chain funds, which exactly is splicing. The idea is, again, quite simple and straightforward. So when you create a new commitment state for the channel, to this state, you not only use the 2 old outputs you have, but you also introduce additional input in case you want to increase the capacity of the channel, and you introduce additional output, on-chain output, in case you want to decrease this capacity. And that's just that. It doesn't really make this on-chain transaction much more complex, but it allows you to dynamically change the channel capacity. There is one complexity. So first of all, technically from the network perspective, when you publish a new commitment on-chain, commitment transaction on-chain to actually change the channel capacity, all the other nodes in the network would think that you actually closed in the channel. So they so to avoid them thinking that the channel with updated capacity is not existent, you still need to re-advertise this updated channel as actually a new channel, which it is introduced another development work to implement this feature. And the last complexity we have here is that you need to incorporate this channel update mechanism into HTLC. For instance, if you want to do it asynchronously, meaning that if you want that your channel is still operational during the process of you updating the channel capacity, you may need to introduce HTLC simultaneously to both old confirmed state and to the new state you create with changed capacity. Having this state synchronized for some times and just dropping the old state once the state with changed capacity would get an out confirmation. It also requires some developers work to do. But once this feature is present, it would make operating the channel much simpler, because basically it would first of all allow you to just do on-chain transaction from the funds locked in the channel with no need to close the channel before that. And secondarily, in case you just want to increase the capacity of the channels between you and partner, you wouldn't need to stack many different channels as you have now, but you would just send one transaction that would increase the channel size you have, completely avoiding all this unnecessary channels micromanagement. And another really anticipated feature, which I think Igor mentioned as well in his talk, because it's also really important for the network, is the introduction of the dual funding. Because currently, when one opens the channel, all the funds are placed on one side, and that's not really convenient, because if you not only want to send money but also plan to receive them, especially if you like a big node or some hub, or I don't know, even just expect some of your friends to send you money, you either need to use external service, which would often take some fee from you for helping with inbound capacity, or you need to negotiate the other party to actually also open inbound channel to you, which makes things a bit complex. If you have lots of channels, you need to manage them again. It's not really finalized on how this would be implemented in specification, but I think the simplest approach that I expect may be introduced in the following. Currently, to save. Currently, there is a certain routine to open the channel between node. Node sends an open channel message, then receives accept channel message, and then does certain handshaking. And today, to save traffic, open channel message contains the minimum necessary amount of details. Basically, just some node data. But there is no problem in introducing additional information to this open channel and accept channel message, so that the node that plans to create a channel may go as far as putting a whole prepared dual funded transaction with specified amounts it expects the other party to put in the channel, and with the accept channel, the other party could the other party could could either approve the proposed distribution funds, return the complete transaction ready to do the funding, or send the contra proposal. So the scheme would, of course, increase the message sizes and would increase traffic in the network a bit, but it would allow to actually negotiate dual funded channels with no need to introduce too much changes into protocol. Yeah. And the other features I also think is worth mentioning is, first of all, there is a definite need to improve routing in the network now, because when the network started, it was decided that for a start, it's enough to stick to really simple gossiping protocol with when all the network nodes broadcast to all its neighbor, all the routing table, which makes things really simple in collecting routing data and planning payment routes. But as the network grows bigger, this approach scales really badly and completely infeasible for the network side. So there are a number of initiatives planned to actually, first of all, optimize the traffic need, and secondary, optimize the process of routing itself. For instance, one simple thing I also think may appear quite soon is the introduction of problem mechanism, because again, to make it simple at the beginning, the problem of route selection was done really simple and straightforward, so that when sender wants to send some money to recipient, he just checks his routing table and finds one path he sees optimal. Then he just creates a routing packet and sends it along the path. If the packet succeeds, then and reaches receiver having all the intermediate nodes set the HTLCs and confirmed they would proceed this transaction, then the settlement starts. If not, then HTLC fail message is propagated backwards, and sender chooses another path and tries again. If it fails, it chooses another path and tries again. It works for the small network, but with a big, really well interconnected network, this could take really long if you have lots of failed attempts. So one easy solution to change that may be in introducing a simple problem message that could be sent not only through one path, but to all potential paths you consider, or at least subsets of paths you consider, so that the nodes on the path would indicate if they are ready to route your payment through the particular channel, and have some timeout set for them, waiting for you to actually send the money through them. Yeah. This sync with routing would become more and more important as the network grows. And another small feature, which is also quite straightforward implemented using the Sphynx messaging approach, is the spontaneous payment. Because as you know, currently to pay through Lightning, you first of all need the recipient to generate you unique payment request, which is good and actually makes sense when you're buying something online. but does not make much sense if you just want to send some money to everybody. There is a way around that called spontaneous payment, when you use this wasted space in a routed packet to actually contain a pre-generated payment request, which recipient would decipher and use in case he gets the payment from you with no prior payment request generated. I think this feature is already implemented in one of the branches of L&D for everyone to try in the wild. And maybe the last, I think, important features for the network that would not appear really soon, I think, but still very important, and I do hope it would be implemented eventually, is an L2 proposed by Blockstream guys with Rosbif. It actually, the complexity of this thing, I mean, why it can be implemented quickly is because it requires an introduction of new SIG hash, no input to Bitcoin, that allows to specify the sequence number of transaction to spend certain output, so that in case collision occurs with two transactions spent in one output, the transaction with higher sequence number is processed by the miners. So, and it's not that easy to introduce things to Bitcoin Core. But if this happens, it would allow to dramatically improve the channel update mechanism, because one of the problems with Lightning now is that for each new commitment, for each new channel state update, for each new commitment transaction, you need to stack all the old states with revocation transactions for all of them. And you can't even lose them, because if you do, the other party could publish on chain the old state, and you wouldn't be able to prevent that. So you have to keep them, and that's again introduces a lot of unnecessary complexity. And with L2, you would just, using this sequence number with SIG hash no input, you would just need to, in case the other party publishes the old state, you just need to publish another commitment transaction with larger sequence number to be accepted to Bitcoin, and you're good to go. And another important implication of that is because the current revocation mechanism because of revocation mechanism that punishes the other side by taking all the funds, it's I mean, this thing also introduces a softer revocation mechanism that doesn't take all the funds if the other party publishes the old state, but just updates the settlement to a more recent state, which is quite good, because sometimes you could just publish the old state with no intention. For instance, you had an outdated backup, and it may not be reasonable to punish you by taking all your funds for that, because you're not really guilty, just not careful. And the last problem, also really important implication of that, is that introduction of L2 would make the information nodes stored about the channel state symmetrical, because I didn't get into these details. This is detail here, but currently the data stored by both channel parties is not symmetrical, which makes it really complex to introduce a multi-party channel, because you have a number of information growing, number of messages and transaction to create growing as square of number of channel participants. And with this thing, with symmetric information, it will be really easy to implement multi-party channels and things like channel factories. I think that's more or less extensive list of features, I think, that are important to protocol, and at the same time developed well enough to in the form of prototypes or ready specifications to be into the protocol soon. So thank you for your attention. It was a pleasure.
Thank you, Pavel. Thank you, Pavel. Thank you very much, everyone in the room. Appreciated that. We're not going to do a kind of WebEx Q&A just because of technical issues. So we're going to move on. But thanks again for presenting. And I'm sure people can get in touch with you. We'll provide details if they have questions for you afterwards. So thanks, Pavel from Lightning Peach.
Okay, if you have questions, you can just mail me. Here is the address. It was my pleasure.